Hello everyone, a very good evening all of you and a very warm welcome to you all to the India's largest, the best and your favorite live learning platform BYJU'S Exam Prep. Can you guys hear me? Am I audible and visible to you all? Please do let me know through the comment section. So you guys are watching me live through the beautiful series which is running on BYJU'S YouTube channel for all the GATE 2023 aspirants. The series is GATE Champion Series. Here we are actually discussing the most important more than 500 questions from each and every topic, each and every subject of mechanical engineering so that your preparation will be better and better for your upcoming GATE examination. Alright. Please do let me know if I am audible and visible to all of you. मेरी आवाज आ रही है क्या आप सुन पा रहे हैं मुझे प्लीज डू लेट मी नो थ्रू द कमेंट सेक्शन कैसे हैं सब लोग व्हाट्सअप नमस्कार आदाब शुभ संध्या गुड इवनिंग सत श्री अकाल अस्सलाम वालेकुम वणकम एंड द टॉपिक फॉर टुडे इज कन्वेक्शन मोड ऑफ हीट ट्रांसफर सबको ऑलरेडी पता होगा कन्वेक्शन इज वन ऑफ द मोस्ट कॉम्प्लिकेटेड important topic for the heat and mass transfer subject. Why? Because convection takes your understanding of two subjects parallelly. One is the understanding of the heat transfer and another is the fluid mechanics. So it is combination of two subjects, fluid mechanics and the heat transfer. That is why the topic becomes very important from your examination. All right. Hi Madhu, Shubhas, welcome. Good evening, good night. Welcome guys, welcome. How are you all? कैसा रहा आपका दिन? All well. Did you revise the concept before coming to the class? So before I start my session, let me quickly introduce myself for those who are meeting me for the very first time. My name is Chandra Shekhar, mechanical engineering graduate from IIT Delhi and also engineering services examination qualified, having more than 10 years of teaching experience, and I am quite comfortable in these many subjects. If you have joined me on the, if you have not joined me on the Telegram yet, I would request all of you to join me on the Telegram. Once you become part of my Telegram group, that is Mechanical by Chandra Shekhar, you will get the notification for all the upcoming examination. You will be getting PDF and notes. Session updates will also be provided to you, and there will be important question given for practice and doubt clarification will also be there. And you can also contact me through the mail ID which is there on the screen. All right. One important announcement before we proceed. Please keep your pen, notebook and calculator because you are supposed to solve the question. I will just assist you with your understanding of the concept. On 6th of September, Ravindra Sir will be taking a special session for all the GATE aspirants, how to crack GATE examination. So please do join him at 8 PM on 6th of September. You should register yourself for joining this session and the registration is completely free of cost. Okay, so without any further delay, let us start with the first question. First and second questions are common data question. Read the question carefully and try to solve. The air which is at 20 degrees Celsius, we can call the free stream temperature of air. Given parameters, the free stream temperature of air is 20 degrees Celsius, is flowing over a flat plate at a velocity. You can call it as U infinity. Free stream velocity is 3 meters per second. The plate is 200 mm wide and 280, length and width L is equal to E is equal to 280 mm or we can say 0.2. And at 56 degrees Celsius, surface temperature is 56 degrees Celsius. The given that the properties of air at the bulk mean temperature, what is the bulk mean temperature? We can also call it as film temperature. The properties of air are to be used at the film temperature. These are the properties of air: density, thermal conductivity, specific heat, and kinematic viscosity, as well as Prandtl number are given. The first part of the question: calculate the average convective heat transfer coefficient. You need to find out H bar. Can you solve it? First step is to check whether the flow over the flat plate is laminar or turbulent, because there is a different formula for H. If the flow is laminar, there is a different formula for calculation of H if the flow is turbulent. So first of all, let us find out Reynolds number based on the length of the plate, that is rho into U infinity into L by mu, or we can say U infinity L by kinematic viscosity. Can you find out the Reynolds number? Can you find out the value of Reynolds number? What is U infinity? That is 3 meter per second. Length is 0.28 and kinematic viscosity is given as 16.768 into 10 to the power minus 6. What is the value of Reynolds number? What is the value of Reynolds number? Can you let me know? The value of Reynolds number should come out to be. Who will tell me? Are you getting 5 into 10 to the power 4 or not? Reynolds number based on the plate length. Are you getting 5 into 10 to the power 4 or not? Kinematic viscosity, because meter square per second is the unit, it is the kinematic viscosity. 5 into 10 to the power 4. Yes. So it is almost 5 into 10 to the power 4, which is less than, it is less than 5 into 10 to the power 5. So the flow is laminar, and if the flow is laminar, Nusselt number, average Nusselt number is given by H bar into L by Kf is equal to 0.664 into Reynolds number to the power 1 by 2 into Prandtl number to the power 1 by 3. From here we can find out H bar. What is that? 0.664 into 5 into 10 to the power 4 to the power 1 by 2 into Prandtl number. What is the value of Prandtl number? 0.7 to the power 1 by 3 into thermal conductivity of the fluid, that is 0.02732. 0.02732 upon L, that is 0.2. Can you find out H bar? What is the value of H bar? Is this clear? If the flow would have been turbulent, can you find out the value of H bar? If the flow would have been turbulent, for turbulent flow, what would have been the formula? For turbulent flow, when the Reynolds number would have been greater than 5 into 10 to the power 5, then Nusselt number would have been H into L by Kf would have been 0.03 into Reynolds number to the power 1 by 5 into, is it 1 by 5 or 4 by 5? Reynolds number to the power 4 by 5 into Prandtl number to the power 1 by 3. That would have been the formula. If you solve this, then your answer should match with option. Can you solve it? Can you get the value? Are you guys getting option A or not? 12.86. Please give me thumbs up those who are getting 12.86. Option A. Very good, Kranti. Well done. Have you understood the question? Have you understood the solution? 12.86. Watt per meter square Kelvin is the correct answer, option A. That is the first part. The second part is what is the rate of heat transfer by convection? How to calculate the heat transfer rate by convection using the Newton's law of viscosity, H bar into surface area into delta T. What is H bar? We have already calculated, 12.86. What is the area? That is L into B into delta T. Delta T would have been, what is delta T? Delta T would have been 56 minus 20 Ts minus T infinity. Put the value 12.86 into 0.28 into 0.28 into Ts, that is 56 minus 20. What is the value of heat transfer? Yes, Narayanan, are you asking something? Bulk mean temperature is the film temperature where the properties are supposed to be used. Are you getting option A, 36.29? Newton's law of cooling or convection, Newton's law of cooling is. Quickly solve the question, quickly get the answer. Your speed and accuracy, these are the two things which are important. Alright. Can we proceed for the next one? Common data question for 3 and 4. Question number 3 and 4. Oil at 25 degrees Celsius, it means the free stream temperature of oil is 25 degrees Celsius. That is given. First of all, always write the given parameters. Flows at a velocity, that is U infinity free stream velocity, that is 0.1 meter per second over a flat plate in a certain process. Alright. The plate is 4.5 meter long and is maintained at a uniform temperature, plate temperature, that is TS, 95 degrees Celsius. The thermophysical properties of oil at mean flow temperature, that is 60 degrees Celsius, is called as film temperature. You can call mean temperature is 95 plus 25 by 2, 60 degrees Celsius. These are the properties which are supposed to be used at 60 degrees Celsius. Calculate the hydrodynamic boundary layer thickness at the trailing edge. Delta at x is equal to L is the first part. We need to find out delta at x is equal to L. Can you solve it? First of all, again we need to check whether the flow is laminar or turbulent. How to check? Reynolds number at x is equal to L. Q infinity L by kinematic viscosity. Put the values. Q infinity, that is 0.1. L 4.5. Kinematic viscosity 0.65 into 10 to the power minus 4. If you solve for Reynolds number, what is the answer? The Reynolds number will come out to be, please check and let me know. Are you getting 6923? Which is again less than 5 into 10 to the power 5. That is for external flow. Flow over a flat plate. For the external flow, Reynolds number, because it is less than 5 into 10 to the power 5, then it is laminar. If it is laminar, delta x is given by 5x upon under root of Rex. For at x is equal to L, you can find out delta at x is equal to L is equal to 5 into L, that is 4.5 upon under root of 96923 meter. What is the value of delta at x is equal to L? What is the correct answer? What is the hydrodynamic boundary layer thickness at the trailing edge? What is the hydrodynamic boundary layer thickness at the trailing edge? Are you getting 270.4 or not? 250? Are you getting 250? Or you are getting 270.4 something? ये क्वेश्चन में एफएम का ही कॉन्सेप्ट है, ये एफएम का ही है. हाइड्रोडायनेमिक बाउंड्री लेयर थिकनेस, इट इज कमिंग फ्रॉम एफएम. प्रथम, आर यू गेटिंग? कुछ गड़बड़ है क्या? 5 into 4.5 divide by under root of 6923. 270.4. It is 270.4. millimeter. If the flow would have been turbulent, if it would have been turbulent flow, how? When Reynolds number would have been greater than 5 into 10 to the power 5. Then delta x is equal to delta t would have been 0.376 x upon rex to the power 1 by 5. That would have been the expression for delta x. But because it is laminar flow, that is why this is the expression is supposed to be used. All right. What is the thermal boundary layer thickness at the same location? The next part is thermal boundary layer thickness for laminar flow. For laminar flow, delta x by delta t is equal to Prandtl number to the power 1 by 3, isn't it? So delta t thermal boundary layer thickness is delta x upon or delta L upon, we need to find out at x is equal to L, Prandtl number to the power 1 by 3. What is the value of Prandtl number? Prandtl number is given as, Prandtl number is not given. The question Prandtl number is not given. But we can find out the Prandtl number from this. What is the Prandtl number? Prandtl number is equal to kinematic viscosity upon alpha, isn't it? We could have calculated Prandtl number, kinematic viscosity upon alpha. It would have been 270.4 upon Prandtl number is kinematic viscosity upon alpha. So 0.65 into 10 to the power minus 4 divided by alpha, that is 7.2 into 10 to the power minus 8 to the power 1 by 3. That will give you delta t. Can you find it out and let me know the answer? Can you solve it? If the flow would have been turbulent, then delta x would have been same as delta t. If the flow would have been turbulent, delta x and delta t would have been same. But if the flow is laminar, then delta x and delta t are related with the Prandtl number. Right? So please guys, do like the session and do share it with everyone else in your friend circle. And do not forget to subscribe our BYJU'S YouTube channel, which will help you to improve your performance, which will help you to improve your understanding of the topics which we bring from time to time. All right. Are you getting option A or not? Delta T at x is equal to L, 27.98 mm. Please do let me know if you are getting it or not. Question number 4. Option A is correct, isn't it? कोई किसी को कोई confusion है तो you can ask. Whenever you have any doubt in the understanding, you can just let me know through the comment section. Otherwise, try to solve. Next question, question number 5 on the screen. A metallic cylinder. There is a metallic cylinder, 12.7 mm in diameter. Diameter is given as 12.7 mm and 94 mm long. Length is given as 94 millimeter. Is heated by an electric heater and is subjected to cross flow of air. There is an air flow. Air. Cross flow of air at upstream velocity, that is V, or we can call it as U infinity, is equal to 10 meter per second, and temperature T infinity of air, free steam temperature, it is external flow. You can call it to be external flow because the fluid is flowing over the surface. Temperature is 26.2 degrees Celsius. The heater power dissipated is 46 watt. The heater power dissipated is 46 watt. Q is 46. Q heater is equal to 46 watt. And the average cylinder temperature, surface temperature is Ts is equal to 128.4 degrees Celsius. If 15% of the power dissipation is lost through cumulative effect of surface radiation and conduction, so the remaining is through convection, through the end places. If 15% of the power dissipation is lost through the cumulative effect of surface radiation and conduction through end places determine the convection heat transfer coefficient H. So can we say Q convection is equal to 85% of Q heater. 85% is lost due to convection. 85% of the power is lost due to convection. What we can say, Q convection, that is equal to 0.85 into 46 watt is equal to H, which is unknown, into area. What is the area, surface area available for heat transfer, into delta T, that is Ts minus T infinity, the value. So H bar is equal to 0.85 into 46 upon pi dl. Area will be equal to pi dl, and Ts minus T infinity, pi into diameter is 12.7 to 10 to the power minus 3 into L is 94 into 10 to the power minus 3 is the area, into Ts minus T infinity. Ts is 128.4 minus T infinity is 26.2. Do the calculation, you will get the answer. Do the calculation and you will get the answer. Can you find it out? Watt per meter square Kelvin. What is the answer for question number 5? Why it is pi dl? Because from the end places, the mode of the heat is lost through cumulative effect of radiation and conduction. So it is only this surface which is available for convection. The convection is taking place from the periphery of the cylinder. That is why the area will be taken as pi dl. Are you getting option A or not? 102.4. Please do let me know. Watt per meter square Kelvin. Are you getting 102.4 watt per meter square Kelvin? Option A. Very nice. Rashad, Madhu Amsi. Good. What about others? बाकी लोग कर रहे हैं कि नहीं कर रहे? Next. Again, common data question 6 and 7. Very beautiful question. A system of heating water from an inlet temperature of 20 degrees Celsius, that is TMI, to an outlet temperature of 60 degrees Celsius. It means there is a heating of water taking place. Water is flowing and it is getting heated from 20 degrees Celsius to 60 degrees Celsius. Involves passing the water through a thick walled tube. The water is passed through a thick walled tube like this. This is a tube, cylindrical tube, having inner and outer diameter of 20 mm and 40 mm. D1 inner diameter is 20 mm and D2 is 40 mm. Inner and outer diameter are given. That is TB1 bulk temperature of the fluid. This is TB2 or TMI and TMO. The outer surface of the tube is well insulated. The outer surface of the tube is insulated like this. And electrical heating within the wall provides a uniform heat generation. The wall is getting heated due to electrical heater. There is a heater like this. And that will produce the uniform heat generation of 10 to the power 6. That is Q dot. Q dot is 10 to the power 6 watt per meter cube. For water mass flow rate of 0.1 kg per second, how long must the tube be to achieve the desired outlet temperature? What should be the length of, in the question, what should be the length of the tube? The question is asking what should be the length of the tube to achieve the desired outlet temperature. If we apply the energy conservation equation for the fluid, if we apply energy equation for fluid mass from inlet to outlet, then what we can say, Q in plus Q generation is equal to Q out plus Q stored. So there is no heat entering or no heat leaving. Whatever the heat generated in the system will be equal to heat stored. ई लर्निंग स्टूडेंट्स को डिमोटिवेट कर रहे हो आप ये बोल के यहाँ पे Q generation is equal to Q stored, isn't it? Stored in the fluid from the energy conservation equation. So Q dot into volume. Q generation is taking place in the solid. Whatever the energy generated in the solid due to electrical heater will be equal to the energy stored in the fluid. So Q dot into volume of the solid, volume of the tube, pi by 4 d2 square minus d1 square into L, that will be the volume, is equal to mass flow rate of the fluid into Cp into Tmi minus Tmo. Isn't it? This will be the energy conservation. The energy is getting stored now. Energy getting stored. Tmo minus Tmi. Put the values from the given question. 10 to the power 6 into pi by 4 into d2 is 20, d2 is 40 mm. It will be 0.04 square minus 0.02 square. The question is to find out L. Can you solve it? Into L. L is the unknown. Mass flow rate is given as 0.1. Specific heat is given as 4.179 into outlet temperature is 60 minus inlet temperature is 20. The only unknown is L. What should be the length? What should be the length? E-learning, it all depends on your interest area. If you are interested to explore your career in the technical field, then IOCL is a better option. But if you want to be part of software industry, then you can go for Microsoft. What is the answer? Are you getting 17.7 meter or not? 17.7 meter. That should be the length. Have you understood energy conservation equation? Whatever the energy generated in the tube, whatever the total energy generated in the tube due to electrical heater is equal to the energy stored in the fluid. Right? 17.7 meter. Option A is the correct answer. The next is, if the inner surface temperature of the tube is 70 degrees Celsius at the outlet. If we talk about the outlet, this is how the tube cross section will look like. If the inner surface temperature, that is, let us say TS2 is 70 degrees Celsius. What is the local convection heat transfer coefficient at the outlet? H2 will be how much? Tmo is 20 degrees Celsius. It is getting heated now. Tmo is 60 degrees Celsius. So what we can say, what is the rate of heat transfer coefficient? What will be the heat transfer coefficient? Can you solve it? You can say the rate of heat transfer is H2 into A2, area available for convection. This is A2 at the outlet, into TS2 minus TMO is equal to Q stored is equal to Q generation is equal to Q stored, isn't it? The total rate of heat transfer due to convection, this is for the fluid, Q convection is equal to this, and Q generation or Q stored you can easily find out. So H2 will be equal to, what is Q stored? M dot into Cp into TMO minus TMI upon A2. What is the area? Area will be pi into T1 into L into TS2 minus MO. Isn't it? That will give you H2. Put the values. Mass flow rate is given as, mass flow rate is given as 0.1. kg per second. Mass flow rate is given as 0.1 kg per second. Specific heat is given as 4179 joule per kg Kelvin. TMO is 60 degrees Celsius. TMI is 20 degrees Celsius. T1 is 20 mm. L we have already calculated 17.7 meter. L we have already calculated 17.7 meter. And TS2 is given as, this is TS2, 70 degrees Celsius. Can you solve it and let me know the answer? Are you getting option A or not? For convective heat transfer coefficient, are you getting option A, 1500 watt per meter square Kelvin or not? Option A is the correct answer. The next question, question number 8 and 9, again common data questions. Experimental test on a portion of a turbine blade having chord length 40 mm indicate a heat flux to the blade of 95 kilowatt per meter square. When the blade operates in an airflow at T infinity as 1150 and velocity as 160 meter per second, to maintain a steady state surface temperature of 800 TS1. If TS1 is 800, T infinity is 1150, there is a heat flow, the heat flux is 95 kilowatt per meter square. The heat transfer to the blade is removed by circulating a coolant Where do we require T mean? Where we do not require T mean. What is the local convection heat transfer? What would have been done is Q dash would have been H2 into TS2 minus TMO. This would have been Q dash, and this Q dash would have been equal to Q generation or Q stored. Q generation will be equal to Q. This would have been equal to Q stored per unit area. That would have been pi into d. That would have been pi into, sorry, d1 into L. So that is how you could have calculated H2. Isn't it? So that is Q dash. Q dash would be equal to H2 into TS2 minus TMO. This is how it should have been. We are applying the Newton's second law for the heat flux. What we are saying, Q convection is equal to Q stored. The total heat transfer rate in the element is equal to Q stored or Q generation. Whatever the energy generated is getting convected. That is the total. That is the total. Even when the temperature is variable. Now we are finding out Q dash from here per unit area. And this Q dash will be equated for the outlet because surface temperature is also changing now. Because the surface temperature is also changing from inlet to outlet. So the surface temperature at outlet is given. And we need to find out H will also change from inlet to outlet. Are you understanding? H will also change from inlet to outlet. Surface temperature is changing from inlet to outlet, and the fluid temperature is also changing from inlet to outlet. That is why we are applying the convection at outlet only. To maintain a steady state surface temperature of 800 degrees Celsius, the heat transfer to the blade is removed by circulating a coolant inside the blade. Determine the heat flux to the blade if its temperature is reduced to. Blade temperature initially is 800. Then TS2 becomes, this is Q-1. So the given parameters are Q-1 is 95 kilowatt per meter square, T infinity is 1150 degrees Celsius, TS1 is 800 and V1 is equal to 16. These are the parameters given. Now we need to find out if TS2 become 700 degrees Celsius. If TS2 becomes 700 degrees Celsius, what is Q dash? What is the heat flux if the temperature is reduced to 700 by increasing the coolant flow when the blade operates in the airflow of T infinity? T infinity is still the same. Now what is Q2 dash? That is equal to H2. Now if we want to write Q2 dash, that is equal to H2 into T infinity minus TS2, isn't it? Do you agree or not? Now we need to find out H2. As we know, Nusselt number is given by H into L by K. Is a function of Reynolds number and Prandtl number. Nusselt number is a function of Reynolds number and Prandtl number for laminar and turbulent. Now Reynolds number is not a function of TS. Prandtl number is not a function of TS. Even if TS changes, then Nusselt number, which is H into L by Kf, remain constant. Do you agree? In the first part of the question, it is only the TS surface temperature which is changing. So there is no change in the Nusselt number. Nusselt number will remain constant or H will remain constant. Isn't it? So H2 is equal to H1. What we can say, H2 is equal to H1. And what is H1? H1 we can write Q1 dash is equal to H1 into T infinity minus TS1. From here we can write H1. Are you understanding? Are you getting it? So H2 is equal to H1 into T infinity minus TS2. And what is H1? H1 can be written as Q1 dash upon T infinity minus S1 into T in. That will give. I hope it is clear. 95 into 1150 minus TS2 is 700 upon 1150 minus 800. That will give you the answer. That will give you the answer. What is the answer? What will be the answer? Are you getting it? Question number 8. Are you getting option B or not? Are you guys getting option B? 122.1. Are you getting option B? Have you understood? H2 is equal to H1. Why? Because neither Reynolds number nor Prandtl number is a function of surface temperature. That is why even if TS changes, Nusselt number will have no impact. And if Nusselt number will have no impact, H will have no impact. So Q2 dash will be equal to H1 into T infinity minus T. Now the second part, determine the heat flux at the same dimensionless location. What is the meaning of dimensionless location? It means same Reynolds number. Reynolds number involves the dimension. The Reynolds number is same. For the similar turbine blade having chord length of 80 meter. Earlier what was the chord length? Earlier the chord length L1 was 40. L1 was 40 meter, 40 mm. Now L2 becomes, for L2 is 80 mm. When the blade operates in the airflow, same temperature T infinity, velocity V2 becomes 80 meter per second. Earlier what was the velocity? V1. V1 was 40 meter per second. Sorry, 160 meter per second. With TS 800. Earlier also temperature 800. This TS1 was 800. TS2 is also 800. And T infinity is also same. Then what do we need to find out? We need to find out the heat flux Q2 double dash. Q2 dash. Again we need to find out Q2 dash. What we can say, Q2 dash is equal to H2 into T infinity minus TS2, and TS2 is equal to TS1. And how to calculate H2? Now, because the dimensionless location is same. Here what is changing? Here L2 is changing, here velocity is changing. L and V, they changes. L and V changes. Because the Reynolds number is same, Nusselt number is equal to H into L by Kf is a function of Reynolds number and Prandtl number. So Reynolds number remains constant and the Prandtl number is the property that will also remain constant. So that will give the constant value. So H is inversely proportional to L. H will be inversely proportional to L. So H2 is equal to, or H2 by H1 is equal to L1 by L2. H2 is equal to H1 to L1 by L2. Can you put the value? So Q2 dash is equal to H2, that is H1 into L1 by L2 into T infinity minus TS2. What is H1? You can put the value of H1. H1 will be equal to, H1 is equal to Q1 dash upon T infinity minus TS1 into L1 by L2. What is L1? L1 is, L1 was 40, L2 is 80. 40 by 80 into T infinity minus TS2. Now these two will get cancelled out because TS1 is equal to TS2 and T infinity is same. It will give 95 into 1 by 2 kilowatt per meter. 95 by 2, that is 47.5 kilowatt per meter square. Option A is the correct answer. Option A. Yes, Rashad. Option A. Yes, Nagaswamy. Option A. Is this clear to everyone? Is it clear? Next question, question number 10 and 11. A plastic pipe thermal conductivity is given, carries fluid such that the convective heat transfer coefficient is 300 watt per meter square Kelvin. H is given. Average fluid temperature is 100 degrees Celsius. Tf is equal to 100 degrees Celsius. Pipe inner and outer diameters are, E1 is 3 centimeter, E2 is 4 centimeter. Heat transfer per unit pipe length is Q by L is given as 500 watt per meter. The external pipe temperature will be equal to, that means Ts. What is the temperature Ts2? If we draw the circuit diagram, there is a fluid, this is Ts2. If we draw the circuit diagram, then we can say there will be two resistances. This is T infinity or Tf, fluid temperature. Fluid temperature is equal to 100 degrees Celsius. This is, let us say, Ts2, outer surface temperature of the pipe. There is a convection. First of all, there will be convection 1 upon H into pi into E1 into L. Then this is R convection, and there will be R conduction. Need to find out Ts2. R conduction will be equal to ln of d2 by d1 upon 2 pi kl. These are the data. We can easily find out Ts2 if Q by L is given. Q by L is given. Q by L is given as 500 watt per meter. We can say Q is equal to delta T overall upon R equivalent. Delta T overall is Tf minus Ts2 upon R equivalent will be R conduction plus R convection. D1, D2 are given. Can you do the calculation and let me know the answer? It is little bit complicated. So Q by L is equal to 100 minus Ts2 upon 1 upon H is given as 300 upon pi d1 pi into d1. What is d1? That is 2 mm, 2 centimeter, 3 centimeter, 0.03 plus ln of 4 by 3 upon 2 pi k. Thermal conductivity is given as 0.5. Put the value of Q by L here. So the only unknown is S2. What is the value of TS2? Can you solve it? Are you getting TS2 as 36.8 degrees? Please do let me know if you are getting TS2 as 36.8. Are you getting it or not? Option A, 36.5 or 36.8. I will share the PDF of this session to my Telegram group. 36.5 something. Yes, Rashid. Good. Question number 11 is overall heat transfer coefficient U on the outside area will be. So Q can be written as Q naught into A naught into delta T overall. Or Q by L. So Q is equal to U naught into pi into D2 into L into delta T overall means T infinity TF minus TS2. From here, Q by L is equal to U naught into pi into. What is the value? Q by L is given as 500 is equal to U naught pi into D2 is 0.04 into 100 minus 36.5 will give you. What is the overall heat transfer coefficient for question number 11? Are you getting Q naught as 62.7 watt per meter square Kelvin? Option B. Are you getting option B or not? Option B. Isn't it? One more question and then we will stop. The last question. From the natural convection, a vertical metallic wall is resting in air at 91 degrees Celsius. Given parameters are vertical metallic wall is resting in, yes, 62.7 is the right answer. So this is the wall temperature, 91 degrees Celsius, and the temperature of the, the vertical metallic wall is resting in air at, that is the free stream temperature of air, infinity. The wall temperature is 159 degrees Celsius. If the properties of air at the film temperature, what is that film temperature? Film temperature is Ts plus T infinity by 2. Kinematic viscosity is given, thermal conductivity of air is given, Prandtl number alpha, and if Nusselt number is given as 0.6, Rayleigh number is 0.25. This is the expression for Nusselt number. The Rayleigh and Nusselt number take the height or the characteristic length as 80 centimeter or 0.8 meter. What will be the value of Rayleigh number and Nusselt number? How to find out the Rayleigh number? Once we find out the Rayleigh number, we can find out the Nusselt number. Rayleigh number is equal to Grasov number into Prandtl number, and Grasov number is rho square G theta delta T L cube by mu square into Prandtl number, or we can write it as Prandtl number is not given. We can write it as kinematic viscosity upon alpha, and this rho square by mu square can be written as kinematic viscosity square, isn't it? One kinematic viscosity getting cancelled out, where beta is what? Beta is equal to 1 upon film temperature, Kelvin inverse. That is beta for perfect gas. For ideal gas, beta is given as, so beta is equal to 1 upon, what is? First of all, we should find out the film temperature. What is the film temperature? That is equal to 159 plus 91 by 2 degrees Celsius. That is 125. So film temperature is equal to 125 degrees Celsius, or in Kelvin plus 273. 298 Kelvin. Is it 298? 398 Kelvin. That is the film temperature. And beta is equal to 1 by film temperature. If you put the value, so Rayleigh number is given by G is 9.81 into beta, that is 1 upon 390 into delta T. What is delta T? 159 minus 91 into L cube 0.82 upon kinematic viscosity, that is given as, Prandtl number is known. We could have used the prompt 25 into 10 to the power minus 6 into alpha. Alpha is given as 38 into 10 to the power minus 6. That will give you the Rayleigh number. Can you find out the Rayleigh number? Are you getting 9 into 10 to the power 8 or not? Are you getting Rayleigh number as 9 into 10 to the power 8 or not? Once you get Rayleigh number, this cannot be correct. This cannot be correct. Once you get Rayleigh number, you can find out the Nusselt number, and the Nusselt number is equal to 0.6 into Rayleigh number 9 into 10 to the power 8 to the power 0.25. Nusselt number will come out to be around 103.9. That will be the Nusselt number. 104. So it is 9 into 10 to the power 8 and 104. C is the right answer. Yes, it's close to 104. So that completes our question practice for the convection. This is your assignment question. There are 3 questions, 13th, 14th and 15th. Please try these questions at home and share the solution on my Telegram group. Shah had given the correct answer for the previous assignment question. Try to solve these questions, question number 13, question number 14 and question number 15. I will share the PDF of this session also to my Telegram group. If those who have not been able to solve these questions, please do try these questions again at home. And tomorrow we will meet for one more time at the same time for 10:45 p.m. and we will discuss the heat exchanger and radiation. The questions from the heat exchanger and the radiation mode of heat transfer. All right. So this is all from my side. If you have not joined me on the Telegram group yet, this is my link to join the Telegram group. And let me take your leave. Stay safe, stay motivated, and keep preparing with your full dedication and hard work. Thank you guys. Thank you very much.